Hello and welcome to another session of classical motion of a single particle. In this session, what we will do, we will address two very interesting problems regarding the motion under a central force. So, we have already discussed the energetics of a particle under the central force as a conservation of energy mainly. So, we have said that the total energy actually can be written like this, mr dot half mr dot square plus L square by 2 mr square plus Vr is equal to the total energy E. And we said that this one is called V effective, the effective potential energy, and this is the effective one dimensional kinetic energy. Okay. And we know that this is the true kinetic energy, and this is the true potential energy. If you have this distinction clear, then you can solve many problems. One typical problem is, let us say I am giving you the orbit of the particle. Okay. So, let us say the particle is moving in a exponential spiral. Let us say the orbit is given like this. So, r is equal to r0 e to the power alpha theta, okay, where alpha is a positive constant. Okay. So, if you have this type of orbit, then the question is find the true potential V of r, so that the total energy E vanishes for the particle at all r. Okay. So, how to address this type of problem? And we know actually for that to the access to the all the constants of motion. So, once again constants of motion, we have the trivial one, this mass, then we have L, this is a constant of motion exclusively true for central force as we have seen, and then also E. Here I have just written L vector is okay, you know L vector as well as modulus of L, both of them are conserved, and E is the total mechanical energy. These three things are conserved quantity and you should know them, because they can be determined either from external sources. For example, mass one has to give you, and this L and E you can determine from the initial conditions, because they are the constants of motion. Okay. Now, I have to find the true potential, that means this part, so that the total energy E vanishes for the particle at all r. That means that if I have to find this one, so that this one is 0, that is the true kinetic energy is exactly equal to the minus of the true potential energy. Okay. So, what will be the style to approach such problems? So, I am just telling you that you have to first understand one thing is that I have given you r as a function of theta. Okay. In this total formula, what you have to find is this one. Okay. Because r I know as a function of theta, what I do not know is r dot. So, I can simply write r dot is equal to dr dt, and you know that this is simply dr d theta dt, and d theta dt is theta dot. So, this is h by r square, and dr d theta I can write like this. Okay. Now, if I write, then h by r square you can also write L by mr square, that is your choice, you can or you cannot. Okay. H is also a constant of motion, so I can also write like this, the constants of motion. Okay. Times, so this one you have to understand, this dr d theta, these you can determine from this information. Okay. So, I have r is equal to this. So, dr d theta will simply be r0 alpha times e to the power alpha theta, and r0 e to the power alpha theta is again r. So, this is equal to alpha times r. So, alpha times r. I can write alpha L by m r. Okay. Now, we have all the elements for our answer. We can now write that what will be the V of r. So, L square by 2 m r square. So, this will be vanishes. So, L square plus by 2 m r square plus this half m r dot square will now be half m r dot square. So, r dot is this, you can write alpha L by m r whole square will be equal to your minus V of r. So, if you calculate it carefully, you will have L square by 2 m r square plus L square by 2 m r square alpha square is equal to minus V by r, V of r. So, your V of r will have L square 1 plus alpha square with a minus sign by 2 m r square. And of course, you see here everything is positive and it is preceded by a negative sign. So, this will be negative, okay, and that is your answer. So, you have to supply us the V as a function of r, which you have given L square, alpha square, m, all of them are constant of motion. Alpha is a constant we have given you. Okay. So, you see that is how you solve this problem. The second problem is a little bit, it is simple, but it is also very interesting. There will be a food for thought, and where exactly I will try to wrap up this session. Okay. So, this is actually will be a very short session with 2 small problems. So, this is that I am giving you, we have already discussed that if I give you some orbit, then how to give me or how to solve for the force law. Okay. You know there are 2 methods. Okay. One is just the formula associating dr d theta, another is the formula using du d theta and their higher order derivatives. Okay. So, we in general use this one, the Binet equation for the sake of convenience, and we know that the law is, so Binet law, Binet equation is d2u d theta 2 plus u, so u is equal to minus f of 1 over u, that is the force law, m h square u square. Okay. Now, I am now giving you the orbit of the particle, which is theta is equal to constant. I can give the orbit as a r as a function of theta, but also I can give you a function theta as an orbit where theta can be given as a function of r, and here I can give you something like that, theta is equal to a constant. Okay. So, how should it look like? Let us say it is theta 0. So, if I just write x and y in a 2D plane, and let us say this is the point P where the particle exists at some instant t, and this is the origin. So, this is the position vector r, and this is r and this is theta. Okay. Now, theta constant means the particle is actually moving in this direction or in this direction. Okay. Of course, this is central force, you cannot say this is not central force, but this is a straight linear motion. Now, how to give the law of force here? So, if you try to derive this thing here, you will see that there is a problem. Now, what is the problem? That your theta is constant. So, I can say d theta dr or d theta du, whatever, they are 0, both of them are 0, and that is why du d theta is equal to infinity. Okay. And if it is infinity, then d2u d theta 2 you cannot just insert in this equation to find a friendly expression for f of 1 over u. Okay. So, it is blowing up. So, I mean of course, you say that you see that theta is a constant and here the main variable is theta. Now, I can tell you a simple way to think why, I mean very simply why this framework is not actually working, and you can then think that whether you can at all can come up with an equation where you will have, let us say something like this, d2 theta du2 or d2 theta dr2 or d theta dr like this. Just you just try on your own. Now, let me explain you a simple method of understanding by which you can understand that this situation is a very strange and typical situation for our case and cannot be solved immediately with our knowledge. What is that? That is, if theta is constant, you know that theta dot is 0, and if theta dot is 0, actually r square theta dot is 0. And what is r square theta dot? This is actually the mod L vector by m. Okay. So, of course, if r square theta dot is 0, m r square theta dot is also 0. So, actually once again you can say mod L is equal to 0. So, although L can have a direction, but L vector is modulus less, I mean L vector has 0 magnitude, okay. It says null vector. If it is a null vector, then you will understand that for our case the analysis will not be applicable, because right from the beginning we start by saying that the r dot L vector is 0 makes the motion in a plane perpendicular to L, assuming that none of r and L is 0. Okay. So, if one of them is 0, we cannot comment easily. Now, I am just closing this small discussion by offering you a very interesting question, that can it be solved at all? Okay. Think about this and you just share your comments or opinion or point of view in the discussion forum. Okay. On this point, I also vividly encourage you to participate in the discussion forums, okay, where in general you ask me questions or some doubts regarding the lecture and the lecture materials, and I will be really happy to answer these things if I can, of course. Thank you very much.